Okay, so last time, so we're trying to kind of demystify all these things with an ultimate goal of moving to a um, getting to the point where we understand that almost all of the software development stuff is based on the same thing. All right, there, we have this mindset that all these things are either magical or difficult, or things have changed over time, and hopefully you're going to see here pretty quick when we talk about RESTful APIs how they really haven't. In fact, most of our things today are just based on very, very, very old things, and we just keep rebranding it or naming it or making small little tweaks to make things better. All right, so last time we started off by talking about, most of our computer programs today, whether you are on your smartphone and have an app or something like that, they're not necessarily running locally, right? They're running on your device, but they're talking to the cloud, they're pulling information from someplace else, this kind of thing. If you're following sports scores, your phone didn't just make up the current score. It's pulling that from some server somewhere, something off your off your device. So historically, we had to have some kind of model for how does in our example here, our phone, the client, talk to the server. All right, we have to have a way of asking for information. Just like if you are trying to find out if a restaurant is open, you pick up the phone, you call them, and well, anymore, you probably go to Google and search for it, but you get what I'm saying. You can call them, ask what their hours are, and you have your information. That's a client server model. So that's kind of this generic model we talked about up here. Well, then we dropped down and we said, okay, well, how does just the normal web-based internet work? When you open up Chrome or Safari or Microsoft Edge, whatever it is, what's that interaction like? Well, we see that it's actually a normal client server model with, and then I put a couple of vocab terms here for these things are commonly called. So we have the front end side or the client side. This is your web browser. And okay, in your web browser on your computer, it understands two things. It understands HTML, that's the data representation language that makes things look pretty on your screen, and it understands JavaScript. That's the programming side of things, the logic side of things, because again, all programming languages have facilities for remembering stuff, asking questions, and repetition. HTML does not have that. HTML has a whole bunch of abilities to make things look bold or have them laid out in a certain way, things like that. It's just about layout. Okay, that's why JavaScript is there to add logic to our client side aspect of our web pages. All right, so the client in this case is our web browser. Other names for it is front end or client side. And the nature of that client in this case is they understand HTML and they understand JavaScript. So the server, whoever they're talking to, however they make that request, ultimately the answer has to come back in a format that they understand, HTML and JavaScript, right? If I call one of these restaurants to find out what their hours are and they're answering me in German and I don't speak German, that's going to be a problem, right? Same thing's true here. Okay, this isn't any different than that. Web browsers speak HTML and JavaScript, so when they ask a question, the answer has to be in the format of HTML and JavaScript, or at least something that JavaScript can interpret. Okay? So when we make a request from the web browser, that request is done using a language. Okay? It's called the HTTP protocol, Hypertext Transport Protocol. Whenever with technology, whenever you see the word protocol, translate that into language. It's a language for doing something. Right now, I'm speaking the English protocol. Okay. So it makes the request using the HTTP protocol. The server, which is just another computer somewhere, probably connected to the internet in the example that we have here. But there's nothing that keeps you from creating a local web server on your computer, so you're actually only talking to your own computer using the HTTP protocol. But generally, if we're talking about applications you might have in your phone or something, it's going to be talking to a server somewhere up in the cloud. All right, we call that the back end or the server side. All right, and here's a couple of the pieces of software that represent web servers. So a popular one is Apache if the server is running on Unix or Linux. That would probably be Apache. Otherwise, if it's on some kind of Windows server, it would be Internet Information Server, IIS. And there's some other ones in the middle for special purpose stuff, but in general, those are your old school large web servers. Okay, and these are things that accept HTTP requests and spit out responses, usually in HTML and JavaScript. All right. So that's what this client server model is here. Web browser makes a request using HTTP, gets a response in HTML and JavaScript, displays the response to the screen. That's the cadence with web browsing, right? All right, this idea of HTTP, Hypertext Transport Protocol, this is a small language, right? It's not as, it doesn't have as many bells and whistles as English. English would be a large language. So HTTP is a small language that knows how to do like 5 to 10 things, okay? And really it knows how to do 4 main things. And we're going to talk about that here in a minute. All right. But the reality is over the years, it's only actually used 2 of those things. And I think we started talking about that last time, the difference between get and post. I think I probably asked something along the lines, have you ever been to one of those websites where you put some pieces of information in and hit the submit button, and then you see your information up in the text of the URL? It's passed it along up there. Okay, that's a GET request, where it takes your information and throws it up into the URL, and that's how that information travels to the next page. All right, that's how, you're on page 1 of a website and you go to page 2 of the website. Where does it get some of that information? Well, it's either going to get it from the URL, if it's a GET request, pull that stuff down, or it'll get it from the HTTP frame behind the scenes if it was a post request. Yeah, you don't visibly see it if somebody was standing over your shoulder, but it's not encrypted or anything by default. So any way you cut it, that data is being sent in plain text unless you encrypt it. So unless you're on a site that has that little padlock thing, and then there's a difference between sending it as a post and sending it as a GET. Get's always plain text up in the URL. All right, but those are 2 ways that web forms send information from page 1 to page 2. All right, but this language, HTTP, has been around since the birth of the internet. All right, so now we have this idea of API. So every nowadays we have software developers who are talking to data sources all over the place, and a lot of those data sources provide a programming interface so that your software can talk directly to that data source rather than having to go through a web page. All right, because going through a web page is actually inconvenient for a computer program. Human beings, we like sitting in front of a web page. We click on a couple of things, we get our data displayed to us on the screen, no programming necessary, right? Okay, but if you're a computer program, clicking around on a screen and reading the stuff that's on the screen isn't quite as easy as it is for a human. It's an inconvenient format in order to digest your data. It doesn't mean it doesn't happen. In fact, we have applications that are usually referred to as something around there's like screen scrapers, right? So applications that open up a web page, look at the HTML and pull out elements from the HTML to get the data they're looking for. That would be in a situation where maybe the data wasn't available through an API. Giving you a quick example of a old school version of that. In the very early days of the iPhone App Store, I had 2 apps up on the store. One was called Quotes RT, the other one was called Portfolio RT. These were stock investing type apps. And this was before there were APIs for talking directly to Bloomberg terminals to get the up-to-date price of Google stock, let's say, something like that. All right. So if I wanted to have an app that could get that information, I needed to acquire it from a different source. Well, at the time, you had Yahoo Finance was one of the main sources. So if you went to finance.yahoo.com, it would bring up a web page that, would have the index prices and stuff. And you could put in the Google ticker, GOOG, and it would show you the current price. Well, so I wrote in my program to read that HTML and go through and pick out the actual price, just that piece of information, and then display it on the screen on the iPhone app, that type of thing. And then I had that for real-time stock quotes, I had it rechecking like every 3 seconds or something like that, so you would get kind of real-time movement of it at the cost of horrible battery life. But in any case, that is one way you could get data, but we can all kind of see how that's inconvenient, right? Human beings like reading from the screen, but computers struggle with that. All right. So these ideas of APIs, they would be kind of the alternative, the computer program's way of digesting data as opposed to a human being looking at a screen. So let's say Yahoo Finance had an API, they probably do now. I haven't looked at it in years, but if they had an API, I wouldn't have to load the web page and then create this hack program that goes through and pulls little pieces of information out of the web page. Instead, I could just talk to the API behind the scenes and say, give me current stock price for Google. You make that little request in the format that they want it, and it will shoot back probably something called a JSON object that has the 5 or 6 different pieces of information, including current stock price. It probably also has market cap. It currently probably has today's high and today's low, that kind of stuff. But I can make a request. It will give me data that's easily digestible by a program, as opposed to a human being who's looking at the screen. Make sense? Kind of the use of APIs. Okay, they're just serving data. Okay, but they're serving data to and from computer programs, not to human beings through a web browser, for example. All right. But again, this API thing is still the client-server model. Client makes the request, the server fulfills that request. Okay, goes right back to going into McDonald's and placing an order and getting your Big Mac. All right, client-server models around us all over the place. All right. So for the, I think you had a homework assignment for today, right? Talking about RESTful APIs versus SOAP-based APIs. What did we find out? What can you tell me about REST APIs versus SOAP APIs? Or what can you tell me about either one of those individual things that you learned about that we didn't talk about in class? Go ahead.
SOAP APIs are like super strict. They have super strict standard. Well, REST stuff, so they can kind of. How I typically use is RESTful. The APIs can kind of fill in the blanks a little bit, and SOAPs have to like be very you have to put in certain things and like be very technical. But
yeah, so I mean, I think at the end of the day, it's less about RESTful APIs being more flexible. I think there'll be a better way of kind of talking about that, but I think the point that was probably being made there is SOAP APIs are finicky. So if you're talking to 3 different data sources, so let's say I'm talking to finance.yahoo.com and I'm talking to Google or finance.google.com, 2 different sites that are kind of giving us the same data. And let's just assume this was an old school example and both of those were using SOAP-based APIs. Well, I might write the code that knows how to make the request to Yahoo's using a SOAP API. But when I go to talk to Google's, I might have to make a couple of little tweaks because their version of SOAP API wasn't quite identical to the one Yahoo Finance was using. So they attempted to make this standard that was mostly standardized, but not completely standardized. So every single time you were going to talk to a different API that was following the quote SOAP standard, you might have to put some tweaks in there to make sure your program was properly communicating with that endpoint. Okay. Again, still an improvement over what it was before that, where every single API just invented their own way of talking to it, right? So if you went back to before we had any sort of SOAP standard, if I was talking to the finance.yahoo API, they would have their own proprietary language that I would have to use for requesting getting data from them. And then if I went to Google's finance API, they would have a whole different made up language for talking to their stuff. So for every API, I'd have to rewrite a majority of the code to talk to them using a different language. I'm talking to English over here. I'm talking Portuguese over here. This guy requires German, so on and so forth. Make sense? All right, so SOAP was kind of our we'll call it roughly our first popular step in that direction. But as you pointed out, it's very strict, it's finicky. You know, not all SOAP APIs were created equal. They were just more equal than before. Okay, anything else you can tell me about what you learned in your research? Go ahead.
This had like flexibility of the REST API. It had like 3 different ways of messaging, whereas SOAP had the one that had
Okay. Yeah, so you know, again, RESTful APIs are very, very, very standardized. And instead of 3, there's really 4, but and we'll talk about them here. So RESTful APIs. And the irony here is when we talk about RESTful APIs, they're not as new anymore. They've been around for several years now, but they're the current, let's say, standard for how APIs speak. But when they first came out, and even still today, they're considered, you know, the new cool kid for talking to APIs. They follow this this REST or RESTful standard. Now, the RESTful standard this guy uses the HTTP protocol. So as a starting point, RESTful APIs are all based on the language that has existed since the birth of the internet. All right, the HTTP protocol, one of the very first things the internet knew how to do was web-based stuff. So anytime that you had a www request, it was done using HTTP from day one of the internet. All right, so this is not some newfangled made up thing. This is something from a long, long time ago. Now, with the HTTP protocol, we started talking about that last time related to kind of form actions, things like that. And over the years, when we think about this protocol from a web page perspective, we only really have thought about it from GET and POSTs, right? Where a GET is your information's up in the text base of the URL. POST is it's sending it behind the scenes somehow. So really, it's just a matter of is it visibly there for the human to see, or would the human have to dig a little bit to get to it? Something like that. But we've really only used 2 of those things, GET and POST. But HTTP also has functions delete and put. All right. So there's 4 different things that RESTful APIs know that HTTP can represent. 4 different function names, if you will. All right. So we can make a request that's a GET request, a POST request, a delete request, or a put request. Now, somebody who came up with the idea of a RESTful API decided, you know what? I could really capture, if we think about the job of APIs, and it's our way of digesting data from another source, from a computer program. I could pretty much capture all the things I might want to do with data in those 4 ways. If you want to retrieve data from the source, so for instance, I've asked Google Finance to give me the current stock price of Google. I am making a GET request asking it to give me some information. Okay. Let's say I'm talking to another data source where I'm updating some value. So maybe a person's changing their password on some website. So now it needs to update the password at the data source to the person's new password. Okay, so I'm not asking for information. Instead, I'm giving it information. All right. Well, that comes in 2 different, we have 2 different functions that can let us do that. If it's brand new information I'm creating for the first time, maybe it's when you're registering an account on a website, I am posting information to that data source, create brand new information and store it. As opposed to if I'm updating an existing account, updating a password, for example, that's a put request. And if I want to get rid of the data that's up there, that's a delete request. Make sense? So 3 of these functions are used for telling the server to do something with the things they already have. The only one that has me getting data from them is a GET request, or has me requesting data. Now, all of these requests might have a response. So for instance, if I say, update my password, blah, 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 with a put, it might come back and give me a password successfully reset or something like that. It gives you a feedback to your program that lets you know whether everything went to plan or didn't. Okay. So in any case, RESTful APIs, they support these 4 types of communication: get, post, delete, and put. Support get, post, delete, put. And sometimes it'll follow something called CRUD. Anybody see in their research that word CRUD? Anybody remember what the different pieces mean? C is for create. D is for delete. R is for either reuse, something like that, or U is update. All right. So kind of just another way of saying we can basically do all the things we might want to do with the data source using 4 different types of requests. Fair enough? Now, maybe we could sit here and debate. Maybe we could say, well, what if the data source was like this and maybe we need a 5th kind of request or something? I can't come up with an idea, but maybe that exists, right? You know, this isn't necessarily a end all, whatever, but at the very least, we can confidently say that, you know what, these HTTP functions fit the things we might want to do with data pretty well, right? You know, kind of covers the gambit. So now, is it possible when you're talking to a data source that you might want to request different kinds of information? Maybe I want the current market cap of a stock, or maybe I want the current stock price, or maybe I want a list of news stories currently related to that stock. These are different kinds of requests, right? All right. So even though all of those would be gets, requests for you giving me information, we then have APIs provide different endpoints for each of those. So we have these things called endpoints. These are the types of requests using the various request methods above. So a API could have 30 different endpoints under their GET requests. Here's 30 different things you can ask the API for, right? And a lot of times, places that expose their data to an API, they don't give you access to everything. Or they give you free access to some things, then they'll sell you access to some other things, that kind of stuff. And there's authentication with them where you have to prove you have the right to ask for the data and that kind of stuff. So these guys come in all sorts of forms, from, a completely open API for getting, information about Pokemon cards, to, APIs where you're talking to a bank or something like that, which you would hope have significantly more security measures put into place for requesting data, and maybe doesn't let you pull social security numbers and that kind of stuff. So these endpoints are the different things that we might be working with underneath each of these methods. So if we think about all the different things we might request from a data source, there would be an endpoint for each of those things under the GET methods. And then all the things we might want to update in a data source. There would be a bunch of endpoints under the put function. Anything we want to add to a data source, there'd be a bunch of endpoints under the posts. Any things that we want to delete, there'd be a bunch of endpoints under the delete, that kind of stuff. Make some sense? All right, so when we talk about RESTful APIs, we have the HTTP methods, and then we have endpoints that fit into one of those 4 categories. All right. So our most modern way to talk to our APIs is through RESTful APIs, which are using HTTP, which has been around as long as the internet has. It's not new. It's really stable because we've been testing it for years and years and years and years. So RESTful APIs are basically archaic, wrapped in a nice fancy new wrapper, and given this I don't know, kind of geeky, mysterious sounding name, RESTful APIs. I don't know. So that's how our stuff works. I think I mentioned maybe the first day of class something about if any of you are web developers. So now hopefully you have a little bit more of an idea. If you didn't know what that really meant, then you have a better idea now. But if you are or know a web developer or have an aspiration to be a web developer, you commonly will be talking to things like this, and you're using something that's been around forever. But if you're a web developer, every 5 minutes, there's a new fancy sounding library that's come out. The examples that I most often use are Ajax, then jQuery, then Angular, or Agile, or React. So these are all fancy buzzwords in modern web development, let's say. And the funny thing is every single one of those is just a JavaScript library. It's not a new technology. It's something that they've already been doing on web pages that they said, you know what, people do this on web pages a lot. So we're going to go ahead and build in this ability into a programming language, kind of like our CPUs, where we're going to add a magic trick. If something needs to happen very, very often, we're probably going to go ahead and give that a magic trick on the CPU. We'll add that the circuitry to do that so that we can just call upon that and it's extra fast. But something that doesn't happen very, very often, we might need to string together 3 or 4 or 5 or 100 magic tricks in order to accomplish something. And that's where human ingenuity comes in, where we have to kind of figure out how do we play with the tools in our toolbox to accomplish a task. All right, but one thing you'll find in technology as you get farther and farther into this is a lot of the newfangled, cool sounding things that come out are just repackaging of old things, usually with some little perk, some update or something like that. But in general, it's not some brand new thing that we've never seen before that's just changed the face of things. Those disruptive technologies, when they come out, we kind of know them 2 years after they hit the market, like the early days of the internet, for example. People didn't see the internet becoming what it became, right? Internet effectively changed the way the world works. Same thing is going to be true with the artificial intelligence stuff. Same thing is going to be true with quantum computing. But until those things become mainstream, until people start putting them into their business models and their workflows, we're not necessarily going to see how impactful they're going to be, but they're going to be very impactful. Same thing with virtual reality. So as technologists, when you're on the, kind of have the inside scoop on this stuff, you see what it's capable of today. You can foreshadow and say, okay, this is where this is going. That's something worth getting into, a skill to learn, stock to invest in, because, for instance, maybe companies dealing with AI or quantum computing, they might be worth something pretty good 5-10 years from now. So it might be worth looking into those because these are future looking technologies that are going to be disruptive. Okay, but every new JavaScript library isn't really that disruptive. It's just its thing. All right. So that's what a RESTful API is. It's a way of talking to these data sources, and we're just seeing repeats of this whole client server model as we go through here. Now, when we talked about making requests to a web server, right here, this client server model, the web server is always sending us our stuff back as HTML and JavaScript. But when we're talking to an API, what format does that information come back as? Anybody find that in your research? What's the answer? When I ask Google Finance to give me the current stock price or give me, information about the Google stock, what format does it come back to me as? Because remember, this is probably my computer program making this request. So whatever it gives to me, I need to be able to easily digest, right? So now we're right back to standards. All right. How many of you, so we can call this, let's call it data standards. How many of you have heard of a CSV file? This has nothing to do with necessarily computer programs. What's a CSV file? Good. Yeah, so if you double clicked on it, it'll probably open up in Excel, right? So a CSV is a comma separated values. So it's a text-based format that allows you to kind of describe data that probably is some kind of spreadsheet format in such a way that a program like Excel can interpret that CSV file and show it on the screen as a spreadsheet that you can now work with. So it is data that is formatted in a specific way that allows programs that understand, let's call it the language of CSV, to do something with. They just know that we have a whole bunch of elements and each one has a comma between it. Make sense? And usually the very first thing in a CSV file tells you what all the field headers are. So then you know how many things are in each row. So if there's 10 things for the field headers, that means that every 10 elements separated commas is a row. Then you go down to the next row, next row, next row. So that's how it's reading in that data. But it's just a bunch of data that's separated by commas. But we do now, so at some point in time, maybe in one of the early APIs, somebody said, hey, we'll just send your request back as a comma separated list. So here's the ticker you asked for, here's the stock price, here's the market cap, yada, yada, yada. Just give it to you in comma separated things. All right. Seems reasonable enough, right? Okay. Well, then you start thinking about, well, are there limitations to that data format? All right. So I would call these guys data representation languages. So CSV file is a data representation language. It's a way to format data so that it could be digested conveniently by somebody else, which kind of sounds like what we want our API, the server, to spit back out to us so we can work with it. It needs to be in a convenient format. So if we think about a comma separated list, we think, okay, well, is this powerful enough? Does this let me do everything I want to do? Well, I already mentioned that the format of a CSV starts off with here's all your column headers, which then tells you how many elements you're going to have in each row and so on and so forth. So you are a little bit limited to the type of data you can have. Every one of your rows basically needs to be the same, right? If you have 10 pieces of information and you have 10 rows, all 10 rows are going to have 10 pieces of information on it, or at the very least send blank information. Put a space in there with a comma on each side, because that's the format of it. It's a strict format. You might also say, well, what if some of the data I want to send back has a comma in it, right? That becomes a problem, right? If the data has a comma in it, all of a sudden, is that data a separator or is that data part of the data? That's a problem, right? Okay. So then what do you think, well, kind of before CSV was kind of like, well, let's say it's kind of the lesser of all the evils. But before that, we maybe came up with proprietary formats, right? So instead of comma separated values, maybe we had values separated by that, or something like that. You know, just random symbols that you think, okay, look, no, none of the data I'm ever gonna, you know, feed to you from this is going to have that as a sequence of characters that's meaningful to the data, right? We just made up a word that's not even, it's based on symbols and stuff. We probably don't have to worry about that being part of the actual data. So do you think probably lots of different people who wrote APIs probably came up with that kind of thing? Yeah, it's like, okay, I need some way of delineating my pieces of information that you've asked me for. Here's my weird, funky separator string that you should separate it on. Good luck. So fine, no problem. But now you write your program to talk to that API, and even if you're talking to it in a RESTful way, a consistent way, now all of a sudden they're handing you data in a whole bunch of different formats. Some of them are speaking English, some are speaking German, some of them are speaking Portuguese. So any way you cut it, you have to interpret the data with a custom program each time. You don't have the set format that people have kind of just adopted. CSV is one of those formats that maybe gets adopted. Mostly it's applied to spreadsheet stuff, but it has some weaknesses. How many of you have heard of something called XML? All right. What can anybody tell me anything about XML? What do we know? Go ahead.
I just learned about it when I was doing my research that SOAP runs on.
Okay, it was common for SOAP to run on XML. It was during a transition thing, but I would say that's mostly true. What else can you tell me about XML? So it's in my column. It's in my my slide here on data standards, data representation languages. So chances are XML is probably doing something similar to the CSV thing. It's giving us data in some sort of format. Now, one thing we might say here with a CSV file, you know, we might say it has limitations regarding commas in the data, and also does not have facilities for describing the data. And if you want to think about the geeky term for that, we would call that no metadata. That's when you see metadata, somebody referencing that, they're talking about information that describes other information. Okay. Well, so here's an example. Let's assume that we've asked an API for a list of the starting lineup of a baseball team. Okay. Well, you're going to get some names and jersey numbers and maybe batting averages, that kind of stuff, right? So 5, 6, 10 pieces of information, whatever it is. Now, those are just going to come in comma delineated lists where you have to know as the programmer, okay, the first thing they gave me is the first name. The second thing they gave me is the last name. Third thing they gave me is the jersey number, so on and so forth. You have to know that that's the order in which the data is coming to you, right? So that when you split it out on those commas, you're putting it, you're remembering that, okay, this is the first name they gave us, and you don't accidentally put that into the batting average column, something like that. Make sense? So comma separated values don't have a way of describing the data on a per data basis. They sort of kind of give us a fighting chance at it by at the beginning of a CSV file, like I said, they kind of list all the columns. All right. So now that you have all those columns listed, then you know, in your data, you can say, okay, well, you know, bucket 0 is the first name, bucket 1 is this name, so is the last name, so on and so forth. All right, but it's not built in on a per piece of data level. XML is verbose, but has the ability to describe data. So for example, I might have a player. So this is some example of XML stuff. And the player has a first name, Mike. and a last name, Lippman, so on and so forth. So notice here that my first name is surrounded by first F name tags. Those tags describe the data that I'm passing along on a per data basis. So I could have one player described like that, and I can have another player described like that. Both of those XML strings represent a player. Now, as a human being, we can look at that and say, oh, they put the tags in a different order, right? But if you're writing a computer program to digest that XML, it doesn't matter what the order is because each element describes the data that's between it. Each tag describes the data. So now we've added this idea of metadata to our to the stuff that might get spit back out to us from like a SOAP API. And even RESTful APIs in the early days would still have XML, but then there was this transition period. All right. Now, anybody see any problems with this that are just initially, they pop into your head? Based on only what I've told you so far, not necessarily what you've read. So just looking at those two lines, what might a concern be? How much data is on each of those lines? It's really just a first name and a last name, right? Mike Lippman. How much extra fluff is here to get you that information? We've probably tripled our data size, our transmission size, right? At least, you know, we could probably take it way worse than that, depending on the nature of the data we're sending. But in this case, we've tripled, quadrupled it, whatever, just to describe a first name and a last name. Make sense? Now, that's not necessarily a problem because at least it does describe it. So we can say this is an upgrade. It's better than a comma separated values, right? In fact, for a long time, well, it's probably still the case for a lot of applications. How many of you have ever opened up a file that had an extension docx, docx? What about a doc file, doc? What program opens when you double click on either of those files? Microsoft Word. What's the difference between a doc and a docx? Docx is a newer format. Doc is an older format. Docx represents your Word document as an XML description. That's where the X comes from. It's an XML-based binary document. All right, so at some point they said, you know what? XML is pretty good at describing things on a page, like what should be bold, what should be underlined, what's a character, you know, what's a new paragraph, what's a footnote, things like that. You can give information like that kind of stuff. All right. To describe how something looks. How many of you ever seen HTML? So this kind of becomes a funny thing. XML versus HTML. So XML stands for extensible markup language. HTML stands for hyper text markup language. Now, if you were to go and look at HTML, you would see things like head, my page / head, body, some stuff. And all that would be inside of an HTML opening, closing tag. Like that. So that'd be a very simple web page. It just has at the very top the header that says my page, and then inside it would just say the word some stuff. Wouldn't look pretty, wouldn't have bold or anything, just there's no pictures, just simple web page. Now, right off the bat, when you look at that, doesn't that look a lot like XML? It's kind of following that tag format, right? There's an opening tag, there's a closing tag with the data in between. All right. Now, what's interesting is XML was born out of HTML. So HTML existed first. And then somebody looked at it and said, you know what? What is HTML? It's a bunch of tags describing data that makes sense for a web page. Well, couldn't we take that same concept and just have tags that describe any kind of data? Yeah, because really parsing out XML or HTML is the same task. You're looking for the opening tag and you're looking for the corresponding closing tag, and then the value is everything in between. You're looking for the opening tag and the corresponding closing tag. Closing tags have a little slash there. And then your data is everything in between. XML is the same thing, right? So what's interesting about this is HTML existed first. And all of our web browsers came out and they understood HTML, but they held it to a different standards, let's say. All right. They held it to different standards. And so if you're a web developer today, one thing you have to do is when you create a web page, you have to test it on the different browsers, because certain browsers might have that page show up differently than other browsers. All right. Just because of the way it interprets HTML. Microsoft Explorer was the king of, let's call it, bad HTML. And in the early days of making web pages, Microsoft had a tool called Microsoft Front Page. So this is years and years and years ago, where people were basically generating web pages using a tool that was kind of like Microsoft Word. So they can drag and drop pictures in there, bold things. So they were creating a word processor document, but then they were saving it as an HTML document. So it was creating the equivalent HTML from whatever you wrote in Front Page, but it wasn't writing very good HTML. It was writing, you know, in some cases it would have a missing closing tag, for example. And because Microsoft Front Page would put out poorly formed HTML like that, and I'm sure when they made that, they tested it on Microsoft Explorer, they had to make Microsoft Explorer's interpretation of XML a little bit loosey-goosey, right? They had to allow it to say, okay, I see you're missing a closing body tag, but well, we'll still let it work. So there's a whole lot of extra stuff in the programming of these browsers to handle all these kind of common exceptions. Now, some of those exceptions are going to be just from human error, right? If we're writing a HTML, you know, we might forget a closing tag or make a typo or something like that. So part of it is just to have some level of convenience to the human beings. But on the other side, if we have a software application like Front Page that's putting out bad HTML for no good reason other than bad programming, and now they have a tool that they've made adapt to the bad HTML that their other tool is putting out, you've now kind of sort of broken the internet. So that's why we have a situation even to this day where different pages might show up slightly different on different browsers. Now, browsers have gotten better and better and better over the years, and the HTML writing tools have gotten more and more accurate over the years. And frankly, we're probably beyond the point now where there's very many pages left on the internet that are were made in Microsoft Front Page. Sure, they still exist, but not very many. All right, so maybe this is less of a problem today than it used to be. But in any case, HTML kind of had this this format that is relatively easy to parse, even though it's very verbose. There's lots of stuff there inside of the pages, with only a little bit of it being data. But at the very least, we can get our pieces of information out. So HTML existed first, then XML was born out of the idea of HTML. Born from the idea of HTML. Now, if you've ever really looked at your browsers, the setting is off by default, but somewhere in your web browser, there's probably a drop-down or a checkbox somewhere that allows you to say, go into XHTML mode. Something like that. Have you ever seen that before? Okay, so XHTML, since XML was based off of the idea of HTML, XHTML is the XML that correctly describes HTML the way it's supposed to be, requiring closing tags and all that stuff. All right, so HTML set the standard for XML, and then they used XML to create HTML with strict standards. And the problem is, if you turn that on in your web browser and you start surfing the web for a day, you're going to notice you're going to run into some web pages that don't look very good, that break, because they don't actually follow the strict HTML standard. They take some side steps. They're missing closing tags, that kind of stuff. So that's why it's off by default. So we can say as computer programmers that, you know what, we really should have strict standards. If we're passing data around and we're using XML to pass the data around, there's a reason we have an opening and closing tag. They need to be there. Okay, it's important that we have correct structure, otherwise our programs break down, because the programs are only as smart as we made them. Well, XHTML is HTML reborn built using XML. And if you turn that standard on in your web browser, half the internet breaks. Probably not half, but I'm guessing maybe 5 or 10% of websites you go to are going to have something quirky on them. So leave that setting off, but this kind of tells a history story of the internet. Okay. So if we were to point out one big problem of XML, we would say that it's pretty verbose. So a lot of stuff is being said with just a little bit of data in there. But now let's look at another problem. This is maybe the bigger problem today. Early days of computing, we really did need to worry about the size of the data because our internet connections were not what they are today. You know, even today, take the beginning of class, folks were talking about their download speeds. We're downloading, somebody was downloading a new video game, probably 100 gigabyte file or something like that, and 100 gigabyte file in dial-up days. Well, first of all, they didn't really exist back then, files that big. But if they did, we can do the math, but call it a year. I mean, hey, let's do the math. So, because we're going to be getting into this stuff from the show Big Bang Theory. Is that a rhetorical question, or would you like to do the math? If you, any of you seen that show, Big Bang Theory? Great show. All right, so if we take 100 gigabytes at a speed of, and we'll even maximize our dial-up speed. So that's 56 kilobits per second. That's the maximum speed of a dial-up modem. So we're just going to take a step back in time and assume we're downloading a modern video game over a dial-up modem. Okay, and get an idea of how long that would actually take, given our conversation at the beginning of class today about, the internet was only going at 700 megabits per second. So first of all, we're dealing with kilobits per second here. We're going to be talking about the conversion stuff here pretty soon. I mentioned I do a lot of conversion stuff, but just to kind of give you the quick math here, let's go ahead and convert the 100 gigabytes into kilobits. So a gigabyte, to go from bytes to bits, we need to multiply by 8. So we're going to have 100 times 8, so we have 800 gigabits times 1024 is in megabits, times 1024 is in kilobits. All right, so we have 838 million 860,800 kilobits of data that you're downloading for that 100 gigabyte file. Our maximum theoretical speed over dial-up, keeping in mind that, you rarely do you actually hit 56 kilobits because there's line noise and stuff like that. But let's assume we did. Divide that by 56. That's the number of seconds. So we got 14,979,657.14 seconds it takes to download that file. So let's divide that by 60. That's the number of minutes. That's 249,660 minutes. Divide that by 24. Oh, actually, let's divide that by 60. That's the number of hours, right? 60. So now we have 4,161 hours. Divide that by 24. We have 173 days. Well, and a third, 173.37 days. So basically half a year. And even at the, whatever the complaint was about the slow speed downloading the file last night, it's probably going to be done sometime today, right? Just kind of cooking, right? And if you had downloaded it at 4 in the morning, it probably would have been done by 5 in the morning. Realistically, right? Because the network, we have plenty of bandwidth that comes to campus, but we also have a lot of students on campus. And so when people are awake and using the internet, you're sharing that overall bandwidth, right? But at 4 in the morning, you're probably one of the few users, except your 40 other classmates who are downloading stuff over BitTorrent and things like that, which, obviously none of us have used. But so you kind of see where we've evolved in terms of connections and things like that. Keeping in mind that a 100 gigabyte file didn't really exist during 56K modem days, but if it did, they're probably going to have the sequel to the game out before you got the thing downloaded. You get the thing finally downloaded, then you realize you're 3 patches behind. And then you realize that each patch is like 4 gigabytes or something. So now whatever it is, right? So just when you think you're done, you still can't play the game because you're 3 patches behind. Then you need to patch it another time. There's at least several days, right? Yep. So you'll be able to do all this stuff here pretty soon, because this isn't hard math, but you're going to notice it is a pattern. So what do we decide? 173.38 days. Fun one. All right. So certainly in the earlier days of the internet, our bandwidth, the speed of our internet connections maybe made us think a little bit more about the amount of data that we're sending around, right? So this idea of XML being kind of fluffy with some extra stuff in there would have been more concerning back then. Reality is today, text is relatively small. Our text today is represented with the encoding algorithm called Unicode. So every character is 16 bits or 2 bytes big. So, you can get a pretty long text document in a pretty small footprint where, if you downloaded a book with a 56K modem, it's still only going to take, 15 seconds or something like that to download the amount of data. It's not a lot of data. Okay. So in any case, we paid more attention to it back then, but today we don't care about text really. So we wouldn't say that's a major problem, but it appears to be, at the very least, it seems to be a waste of space. Not as efficient as it could be or should be, something like that. But the other problem, I would say the bigger problem. So we're going to say actually, let's go back to the previous page to put this guy, right? So XML is verbose, but has the ability to describe data. So that's good. But we're going to say does not have the ability to describe collections. And what I mean by that is, let's assume we were asking for the players on a baseball team. All right. And let's say there's 20 players on the team. I'm going to get a document that just has 20 lines that look like this. It won't be wrapped in something that says, here's a collection of the documents, right? It won't be wrapped in, I think there's a plug right here in front of your, isn't there a plug right there? So it doesn't allow you to have a collection that says, here's a whole bunch of players. Here's your data. Go ahead and iterate through it and get whether it's 5 players, 200 players, 10,000 players. It can't describe it that way. Instead, it can just give you the information for all 2,000 players. And then you have to have the code on your side, the parser that goes through it just says, okay, I'm going to keep looking for players until I don't find any more players. All right. You can pull it off. It's not something that really limits you other than just being inconvenient. All right. So today, what's the format of the cool kid today? What's the format that most APIs today use? JSON? This guy. Do you know what JSON stands for? JavaScript Object Notation. Now, before long here, we're going to be talking about, we already have our first slide towards this where we talked about there's different kinds of languages, machine language, low level, high level. You know, we're going to be talking about there's different kinds of languages. We have procedural languages and we have object-oriented languages. So we'll talk about what the difference there is. JavaScript is an object-oriented language, but the object-orientedness of it was added later. So it started off as a procedural language based off of, you know, like C, the C programming language. And then they added the ability for it to deal with objects. And the way they did it is through something called JavaScript object notation. So this is something that was born in the JavaScript language first. And then they brought it out and said, hey, we can use this to describe data. So as an example, we would say JavaScript starts with an opening and closing curly brace. So it already looks more codey to programmers than the HTML stuff. So we might have something like F name is Mike, L name is Lippman. So this guy right here represents the same data as this guy right here. So seems a little bit more efficient. And each piece of information is labeled. So we can switch this around, change that to L, Smith, change that to F, John. So there's the equivalent of the 2 XML lines above using JSON. Didn't matter what order they were. JSON says, here is a collection of name value pairs. All right. If you've ever coded, how many of you have ever done anything with Python? Okay. Python has a data type in it called a dictionary based on JSON. All right. Bunch of name value pairs. Okay. You have a piece of data, say, give me the first name. It'll pull out Mike from that if that was the JSON we were dealing with. Make sense? But what JSON also then lets us do is it lets us, we're going to say, supports arrays. So we're going to put open and close square brackets on there. We're going to put that guy in there. And we'll put a comma, then we'll put that guy in there. So now we have a collection of players that JSON now supports. That opening and closing square bracket in JSON is an array. And pretty soon when we get into coding and we write arrays in here, You're going to find that opening and closing square brackets is what C++ uses for arrays. Very programming centric. The decisions made for representing stuff in JSON are using symbols that are very familiar to computer programmers. All right. Not only does it give us pretty decent structure, I mean, programming languages by definition are pretty structured, but it also is going to be nice. And the people who are likely using the data that's coming out of an API are typically writing code that's working with a big JSON document are going to be programmers, and they're going to appreciate this format more than this format. Even though there are already tools built into many programming languages for parsing XML. You know, where you can just say, give me the data contained in there, and you pass it this XML string and it pops out a collection of stuff. Or you can write it yourself and do it. It's not overly hard. It's just tedious. And if somebody already did that job for getting your data, you might as well get the data as soon as possible, then start solving your real problem, right? All right. But we can at least all look at this and say, okay, that seems better. It's an improvement, right? But that format was born inside of JavaScript, hence the name JSON. And brought over to say, hey, we can use this to represent data. It's just a bunch of name value pairs. Make some sense? All right. And it also supports collections, even though, like I said, we could pull that off with XML. You can write a custom program that goes through and says, you know what, I'm just going to keep looking for opening and closing player tags until I run out of them. And I'm going to just keep adding them to a collection somewhere. I'm going to assume I won't have more than 1 million players. So I'll create an array with 1 million buckets in it. And then I'll go through and I'll find all my players. Presumably it's less than 1 million. And I'll fill it up and just keep track of where the last one was. That's like the coding hack to use XML to represent collections. JSON takes that and upgrades it, let's say. All right, questions about any of that? Okay, so next time we're going to come back and we're going to, let me just create a slide since we're right on it right now. 3 kinds of programming languages. Functional, procedural, object-oriented. Start here. All right, I will see everybody on Thursday. Later. Hey, Ben, I saw your message just now that you put in there. In the future, if you have a question, just speak up, interrupt me so I hear you. Otherwise, I'll miss the chat messages. So, yeah, I got my volume turned up, so always feel free to just scream at me. I'll roll with it. But to your question, what did you say in your question? No comma, and that's using extra storage. Well, you can't have the comma in your data. I know you've already left, but I'll have it on the recording here. You can't have a comma in your data because now your data is no longer separatable by commas with the computer program. So a comma in CSV means separate my data, not be part of my data, because then it's going to confuse your program as to whether or not you're talking about separating pieces of information or is it actually part of your information. All right. What's up?